Hello. Today we're going to look at the equations of motion. When you're studying the chapter of kinematics, you will basically be using three equations. Uh, the most important are the first two, and we will show you in this video how to get the third one from the first two. Okay. First of all, I want to remind you that V stands for final velocity, U stands for initial velocity. The A stands for acceleration, T stands for time, and S stands for displacement. Okay, so what are the equations of motion? The first equation of motion, you can obtain it directly from the definition of acceleration, because acceleration is the change in velocity over the change in time, over time. Okay, so a change is always the final velocity minus the initial velocity. And if we consider that we start time in t equals 0, so initial time is 0, then this is t. Okay, so basically we can rearrange this by doing at equals v minus u, and then keeping v as the subject of the formula, we obtain this first equation of motion that gives us the value of the final velocity uh, depending on the initial velocity, acceleration, and time. Okay. Second equation of motion gives us the space. Okay, so again, we will show you how to get to this one when we do integrations. We will do another video about how to obtain this one. But basically, it says that the change in speed equals ut plus half at squared. That's one way to see it. Another way to see it, and the way I normally use it, is that S equals final displacement equals initial displacement plus ut plus a half at squared. Okay, that's the second equation of motion. Okay, a way to remember those equations of motions is if you consider that you have S, and then so displacement, then velocity, and then acceleration. Equations give you also always give you whatever you are measuring, in this case displacement, equals the initial thing you're measuring plus the next variable you measuring multiplied by t, and the next one multiplied by a half at squared. Okay, so that's the speed. If we follow this method here, the variable that we're measuring, then we have the same variable with the initial value, and then the next variable with the t. Okay, that's a way to remember those equations of motion. Okay, and we said that there was a third one. The third one is useful because it doesn't depend on time like the two previous one do. But I'm going to obtain it mathematically from this two. Okay. With the first two, we can solve every problem, but sometimes we can get faster to the solution if we use a third one. Okay, so in the first equation of motion, I am going to put t as the subject of the formula. So if we do that, we rearrange that. U goes to the other side, and then a goes dividing. Okay, and we're going to substitute this in the second uh, equation of motion, which is this one, and we are going to consider, like we did with the time, that the initial space is 0. Okay, so if we do that, we have S equals 0, which we don't write it, U, and we substitute t by v minus u divided by a. plus a half a v minus u divided by a squared. Okay, so let's start simplifying a few things there. Okay, so if we do this here, we do the multiplication, we can obtain uv minus u squared divided by a. And then here in this side, we have a divided by a squared, which obviously we can remove an a there, and then here we have v minus u all squared, which is perfect square. We get the v squared minus 2uv plus u squared. Okay, I am considering that you are familiar with the perfect squares and you can do that. If not, just do this, which is that that numerator, and then do the multiplication and you'll obtain the same thing. Okay, but I recommend you to get familiar to with the perfect squares. Okay, so here we will then have two fractions. One fraction is divided by 2a and is basically that perfect square which we had before, and the other one is divided by a, and the other one is divided by 2a. So we want to turn it into the same fraction. The common denominator is 2a. In the first one we had a, we want to have 2a, so we have to multiply everything by 2. And then we're going to add the other part. Okay, so let us simplify that. If we have s equals the fraction is 2a, and then let's see what we have here. We have a v squared. We have 2uv and minus 2uv, which we can subtract there. We can remove, and we've got minus 2u squared plus u squared. That's a minus u squared. So that's what we have there. Okay, so if we're going to again rearrange this and leave the final velocity as the subject, we have v squared, that goes there multiplying, so it's 2as, and then minus u squared goes to the other side with plus. Okay, so if we rearrange it again, we normally write it like this. Okay, so this is an equation of motion you have to get very used to. Sometimes you find it like this. You should learn it by heart. Sometimes you can find it like this, with h the height. Sometimes the acceleration is the gravity. In those cases, you have that. Okay, but they're all parts, and sometimes initial speed is 0, so sometimes you get this formula, which is a free fall formula. But the general way is that one. And as I said, it is very useful because it does not depend on t. Okay, so these are the three equations of motions, the three that you should learn, the three in green. First two are the most essential ones, and I showed you a trick on I showed you what each term means, and I showed you a trick on how to remember them, and they depend on t. Get very used to those and learn them, and be able to produce them whenever you need them. I normally write them down at the start of the exam. Okay, and the third one you should learn by heart, although as you can see, you can obtain them from this first two, but it's not a thing that you should do in an exam. So I recommend you to learn it by heart. And those are the three equations of motions which you will use in kinematics and solve all of your problems. Okay.